So I'm starting with today's discussion. So we were dealing with pressure measurements and velocity measurements, and we learned that we could essentially use Bernoulli's equation or Bernoulli's theorem to find out what are the flow rates, what are the pressure differences, what are the pressure drops across the tube length. So one of these measurement devices we have already done. This is for pressure measurement. Any doubts in this pitter tube, because we have discussed this number of times? So I will not go into details of the construction and all that. If you have any doubts, you can ask me regarding pitter tube. Any doubts in this configuration? Any doubts? So what are, if I ask you, you are able to see two things. One is fluid will be flowing in through this, and the other is fluid will be flowing through this. So what do you think? Which one of will measure static pressure and which one of them will measure dynamic pressure or total pressure? Sorry. Hans. Anyone? Anyone? This is a better example which will help you to understand which one is measuring which. So I have got one answer. So red will measure the total pressure and blue will measure the static head. So this was red, that is fluid will get stagnant and you will, whatever you measure is the total pressure, whereas these are measuring static pressures. So you are able to see. So the benefit here is instead of making two holes, you can only make single hole and you can measure static as well as the stagnation pressure between the two. And you can measure the difference and that will give you the dynamic head. So this is integration of both the limbs into a single tube. And this is the actual view of this pitter tube. So you are able to see this part is analogous to this part. And this part, you are able to see small holes. So these are these holes. Any doubts to anyone? So these measure static pressure and these measure stagnation or total pressure. Any doubts to anyone? Clear? And if you want to measure the difference between the two, that is, you want to find out what is the dynamic head, you take the difference of the two measured pressures, you get this dynamic head. Any doubts to anyone? Any doubts? So now I'm coming to flow meters. These are called obstruction flow meters. You can have other flow meters also. Those flow meters will not obstruct the flow, but will help you to measure the flow rates or the velocities. So these types of obstruction flow meters were actually very famous in earlier 21st century, and now also they have some practical utility. So most of the pipings you will see these kinds of flow meters installed on those pipe fittings and all those stuff. This helps us to measure the flow rate essentially. So if you want to find out flow rate, say this was a tap, you want to find out what is the flow rate. How will you measure the flow rate in this tap, out of this tap? What is the easiest way? If you want to measure it, say you have at your home in the kitchen, you have a tap, you want to find out the flow rate of the tap. How will you find it out? will you find out the flow rate?
सर टैप ऑन कर देंगे, जितना पानी बाहर आएगा उसके कॉरेस्पॉन्डिंग टाइम नोट पे कर लेंगे, उससे फ्लो रेट आ जाएगा.
Okay, so you will measure, you will keep a stopwatch or a simple watch. तो इसमें जितना पानी भरेगा and you will note the time. So volume upon time elapsed will give you the flow rate. So if this is so simple, why do we require these special kinds of flow meters then? This is the direct measurement. That is, you are directly measuring the flow rate. But we are talking about, say, Orifice meter. We will Orifice meter, then nozzle, then Venturimeter. Then why do we require such kinds of obstruction flow meters? What is the practical difficulty in this kind of measurement? Anyone? First of all, if there was a very complicated piping system, so this was a very complicated piping system, then you require, first of all, if it was water or something else, first of all, can you actually measure real-time flow rate in the piping system? What do you mean by real-time? What do you mean by real-time? What is the practical difficulty in such kind of system? If there is fluctuating flow and the flow rates are changing, can you measure with this method? Anyone?
वो तो एवरेज देगा ना.
वो average देगा, so you will not be able to find out the instantaneous value. Any other practical difficulty? You will have to keep one end open, and that may not be practical in certain cases. And clear hai? Moreover, if you have some kind of other liquid which cannot be actually exposed to the atmosphere, then also you cannot use this kind of a stuff. Any other thing? What about gases? Can you use such method in case of gases?
No sir.
So there will be difficulty because the compressibility effect will be there. So there will be different pressure here in the tank and there will be different pressure in the pipe. So the measurement you have taken might differ from this. If you want to take the same measurement, you will have to maintain the same pressure as well in the tank as well, what was in the pipe. So those are the practical difficulties, and to overcome those practical difficulties, these were the first attempts. That is, we devised certain kind of meters, and these were called obstruction flow meters, which we actually installed within the pipe, and we were able to find out the flow rate, the velocity, the pressure drop. So the essential premise behind flow measurement was Bernoulli's principle, because we know that along a streamline, if there are negligible head losses, then we know that P upon rho g plus V square upon 2g plus y is a constant. So this principle we are utilizing to find out what is the flow rate. Are you clear? So these are the three types of commonly used obstruction flow meters. First one is called the Orifice meter. Second one is called the nozzle, this one, and third one is called the Venturimeter. So what do you think is the essential difference among the three? You are able to see the construction of all the three. So what do you think is the essential difference among the three in terms of construction? This is just a plate with a hole. So this is called orifice meter or orifice plate. This plate itself is called orifice plate. That is, this is a plate in which you have drilled a hole. Nothing more than that. So what do you think? How can you actually determine the flow rate by this kind of a flow meter? What will happen? Where will you take the streamline? Where will you measure the pressures? So I have this here, this here. So this is 0.1, this is 0.2. So what do you think if I connect these? If I connect these like this, say, so in which side will be the pressure greater? Anyone? On which side of the limb? On which side of the limb will these be? Will the height be higher, here or here? I've connected them through a manometric pipe. My question is, in which limb should I show the manometric head to be higher? Anyone?
Second one.
Second one.
Yes.
What does that tell you? It means, say, I have this fluid here, and here the fluid will go up till this location, and this is the manometric fluid. And this is your answer?
So something like this. Yes, sir.
So what has happened is, why this thing, or it should be the other way around. प्रेशर कहां पे ज्यादा होगा? इस लोकेशन पे ज्यादा होगा कि इस लोकेशन पे ज्यादा होगा?
सर पहली वाली लोकेशन पे ज्यादा होगा प्रेशर।
तो यहां पे प्रेशर ज्यादा होना चाहिए। क्यों?
क्योंकि सर यहाँ पे वेलोसिटी कम है,
यहाँ वेलोसिटी कम है। So please remember, this configuration should be the other way around. That is, this should be higher at this location, and so that the pressure here is higher. So pressure here, say I mark this as 1. This is pressure at, say, 2. So pressure at 1 should be greater than pressure at 2, because I know that V2 is greater than V1. Because by Bernoulli's equation, if there is negligible pressure drop or head loss along the streamline, then I know that sum of all these heads should be a constant. So velocity is increasing from 1 to 2. It means the static pressure head should decrease so that this remains a constant. And is that clear? Any doubts to anyone? So pressure at 1 should be higher as compared to pressure at 2, static pressure head, because the velocity at point 1 is less as compared to velocity at 2. Any doubts to anyone? Now let me know, how will the fluid flow through an orifice? Orifice or say a nozzle. ये तो आपने orifice देख लिया. उसके नीचे एक nozzle पड़ी है यहाँ पे. This is the nozzle. So what do you think is the difference between this configuration and this configuration? What is the difference? This is also obstructing the flow. This is also obstructing the flow. So what do you think is the difference between these two? Anyone? This is a nozzle. This is the orifice plate. What do you think is the difference between these two? And Anyone? What do you think is the difference between these two?
सर इसमें स्मूथली मतलब एकदम तेजी से मतलब उसका जो एरिया है कम नहीं हो रहा, मतलब
हाँ,
एरिया कम हो रहा है, मतलब बहुत लंबे समय तक एरिया कम रहेगा।
तो इसमें जो ट्रांजिशन है वो स्मूथ है और इसमें ट्रांजिशन जो है वो सडन है। हाँ जी, क्लियर है? हाँ जी, ये क्लियर है आपको? एनी डाउट्स टू एनीवन?
नो सर।
इसमें फ्लूइड ऐसे फ्लो कर रहा था, तो ये स्ट्रीम लाइंस हैं, तो एकदम से क्या होगा, ये इस तरह से हो गया। ठीक है, तो इस रीजन में क्या होगा आप ये मुझे बताइए। मैं यहां पे ड्रॉ कर रहा हूं, 1 मिनट। आर यू एबल टू सी व्हाट विल हैपन इन दिस रीजन? एक तो ये फ्लो कर रहा है यहां पे से, मान लीजिए मैं यहां पे ड्रॉ कर रहा हूं, आई एम ड्रॉइंग विद रेड लाइंस, से दिस इज द स्ट्रीम लाइन। ये स्ट्रीम लाइंस हैं, स्ट्रीम लाइंस हैं जो फ्लो को दिखा रही हैं। ये स्ट्रीम लाइन ऐसे चली गई। तो मेरा क्वेश्चन है यहां पे क्या हो रहा होगा इस रीजन में? इस रीजन में फ्लो हो रहा होगा कि नहीं हो
इतने
रहा?
से स्टोर हो जाएगा सर, स्टोर हो जाएगा एक तरह का।
तो स्ट्रीमलाइन ऐसे होंगी, इसका मतलब क्या हुआ, इस रीजन में कोई भी फ्लो फॉरवर्ड डायरेक्शन में नहीं हो रहा, यहां पर रीसर्कुलेशन हो रही होगी।
सही, बाउंड्री लेयर की वजह से।
नहीं, बाउंड्री लेयर तो है ही है, बाउंड्री लेयर की वजह से नहीं, वो क्यों हो रही है? क्योंकि यहां पे देखो क्या था, जो यहां पे स्ट्रीमलाइन आ रही थी वो बाउंड्री से अटैच थी बिल्कुल। अब यहां से उसका बाउंड्री से कनेक्शन ही टूट गया। आप समझ रहे हो? यहां से बाउंड्री से कनेक्शन ही टूट गया। इसको ऐसे सोच के देखो, मान लो ये जो होल था, ये होल ऐसे होता। अब मैं शो कर रहा हूं आपको, मान लो इतना ही होल होता है, ये इतना सा होल होता, तो क्या होता? और एक और केस बोल रहा हूं, ये इतना होल होता। दोनों केस में क्या फर्क होता? दोनों केस में क्या फर्क है? इसमें होल बढ़ा दिया मैंने, सो इन दिस केस द होल इज दिस बिग, इन दिस केस द होल इज वेरी स्मॉल।
दूसरे वाले में जो प्रेशर चेंज हो रहा है वो ज्यादा सडन हो रहा है एज कम्पेयर टू पहले वाले।
हाँ, तो अगर मैं इसको 1 बोलूं, 2 बोलूं, 3 बोलूं, सबसे कम बाउंड्री से डिटैचमेंट किस केस में होगी?
टू
नंबर
में।
2।
2 में।
यस सर।
सबसे ज्यादा बाउंड्री से डिटैचमेंट किस में होगी?
नंबर 3।
नंबर 3,
3।
क्योंकि यहां पे स्ट्रीमलाइन या ऐसे आके क्या होगी, ऐसे जाएगी। आप समझते हो ये?
यस सर।
तो जो ये रीजन होगा आपके पास, ये वाला, यहां पे क्या होगा? रीसर्कुलेटरी फ्लो होगा।
एडी फॉर्मेशन सर।
हाँ, यहाँ पे आपके पास एडीज फॉर्मेशन या वॉटेक्स होगी, दैट वी विल स्टडी इन आवर लेटर क्लासेस। सो देयर हियर द फ्लूइड हैज एक्चुअली डिटैच्ड इटसेल्फ फ्रॉम द बाउंड्री एंड वी डोंट वांट दैट, क्योंकि एक्चुअल में जब ऐसे होता है तो प्रेशर ड्रॉप होता है। हाँ जी, क्लियर है? क्योंकि आपने ये तो प्लेट किस लिए लगाई है? फ्लो मेजरमेंट के लिए। अगर मेजरमेंट की वजह करते करते प्रेशर ड्रॉप हो रहा है, इसका मतलब पाइप में प्रेशर ड्रॉप बढ़ रहा है इस वजह से, प्लेट लगाने से, तो इसका नुकसान क्या है? तो इफ यू
सर
वांट टू मेंटेन अ
सेम
फ्लो,
टेम्परेचर पे सर अगर प्रेशर कम होगा सर फिर वो बॉयल होना शुरू हो जाएगा।
नहीं नहीं, वो तो बहुत एक्सट्रीम केस में जो आप कह रहे हो, वो तब है कि वेलोसिटी बहुत ही हाई हो जाए।
अच्छा।
हाँ, वो बॉयल हमेशा नहीं होता, उसको आप बोलते हो कैविटेशन। यू माइट हैव हर्ड अबाउट
Yes.
कैविटेशन। तो कैविटेशन इज जब वेलोसिटी बहुत ही हाई हो जाए तो जो स्टैटिक प्रेशर है वो बिलो एटमॉस्फेरिक पहुंच जाता है, और उस टाइम पे लोकलाइज बॉइलिंग स्टार्ट हो जाती है। और जब वो बॉइलिंग स्टार्ट होती है, जो बबल्स बनते हैं, जब वो इस वॉल पे इंपिंज करते हैं, वो इसको इरोड कर देते हैं। So that is a phenomena that happens when there is very high velocity. तो अगर आप ऐसे मान के चलें कि अगर आपके पास इस तरह से था, कुछ एक पाइप थी, इस तरह से था जिसमें एरिया भी छोटा हो रहा था और यहाँ पे वेलोसिटी बहुत हाई होगी, एरिया इतना छोटा हो गया, इतनी बड़ी पाइप थी, मान लो बहुत बड़ी पाइप थी, और एकदम से ये वेलोसिटी बहुत हाई होगी यहाँ पे, तो क्या होगा, यहाँ पे जो प्रेशर हो जाएगा वो बहुत लो होना स्टार्ट हो जाएगा, इट विल गो बिलो एटमॉस्फेरिक। तो एटमॉस्फेरिक प्रेशर से ही प्रेशर जो है वो कम हो जाएगा। और जब ही आपको पता है बॉइलिंग कब स्टार्ट होती है, when does boiling start? हाँ जी,
So
when
the
does boiling start?
वेपर प्रेशर और एटमॉस्फेरिक प्रेशर सेम हो जाए,
सेम हो जाए, ठीक है। आपने ये चाहे अपनी छोटी क्लासेस में सुना होगा, मान लो हम हिल स्टेशन पे चले जाएं और आप कुछ कुक कर रहे हो तो पानी बॉयल होना स्टार्ट हो जाता है लेस देन 100 डिग्री सेल्सियस पे, ये चीज आपने देखी होगी। तो अगर आप जाएंगे, जैसे मान लीजिए आपने कोई भी चीज कुक करनी है एंड यू आर एट अ वेरी हाई एलिवेशन एंड एट दैट एलिवेशन प्रेशर इज एक्चुअली लो, तो प्रेशर लो होने की वजह से यहां पे लेस देन 100 डिग्री सेल्सियस पे ही बॉइलिंग स्टार्ट हो जाती है। सो प्लीज रिमेंबर, व्हेन यू से 100 degree Celsius is the boiling temperature, it should be always clarified this is at
sea level,
1 bar or 1 atmosphere, 1 standard atmosphere. This value will change when this pressure will change. तो आप अगर मान लीजिए प्रेशर आपके पास 10 बार है, so even if the water is 200 degree Celsius, this will be in which state? Liquid state. तो प्रेशर को बढ़ा के आप उसका बॉइलिंग को सप्रेस कर सकते हो, प्रेशर को कम करके उसकी बॉइलिंग को पहले ही कर सकते हो लोअर देन इट्स स्टैंडर्ड बॉइलिंग टेम्परेचर। सो दैट वाज द कॉन्सेप्ट। सो दैट्स व्हाई कभी भी आप देखते हो पाइप्स के अंदर या कहीं पे भी, यू ट्राई टू अवॉइड सब एटमॉस्फेरिक प्रेशर बिकॉज दैट कॉजेज लोकलाइज बॉइलिंग। और लोकलाइज बॉइलिंग से क्या होता है, जो वहां पे लिक्विड प्रेजेंट होता है दैट एक्चुअली नाउ स्टार्ट फॉर्मिंग बबल्स, और बबल्स वो जब स्ट्राइक करते हैं उस मशीनरी की सर्फेसिस को, तो उस मशीनरी की सर्फेसिस को ही इरोड कर देते हैं, एंड दैट इज वन ऑफ द कॉजेज ऑफ फेलियर ऑफ दोज कंपोनेंट्स। सो जैसे आपके पास टरबाइंस होती हैं, तो टरबाइंस में लो प्रेशर एरिया क्रिएट हो सकता है एंड यू कैन एक्चुअली हैव cavitation on the turbine blades. So that should be very clear in your mind. हाँ जी, clear है? So what we have seen is there are 3 types of flow meters, and in flow meters we have seen one is Orifice meter, one is nozzle, and the third one is what? Venturi. And I am giving you a hint, तीनों में इसी डायरेक्शन में इंप्रूवमेंट हो रही है। इसमें सबसे ज्यादा प्रेशर ड्रॉप होता है, इसमें उससे कम होता है, इसमें सबसे कम होता है। नाउ व्हाई डू यू थिंक इसमें सबसे कम होना चाहिए? व्हाई डू यू थिंक देयर शुड बी लेस प्रेशर ड्रॉप इन दिस केस?
पर बाद में उसकी वेलोसिटी इंक्रीज भी तो कर रही है ना।
हाँ, बाद में क्या हो रहा है उसका, हमने एरिया क्या कर रहे हो आप?
बढ़ा रहे हैं ना, बाद में इंक्रीज कर रहे हैं।
एरिया बढ़ा रहे हैं तो हम प्रेशर इंक्रीज कर रहे हैं।
यस सर।
तो बेसिकली वेंचुरीमीटर में देयर इज लीस्ट प्रेशर ड्रॉप। तो जब आप वेंचुरीमीटर लगाएंगे अपने मेजरमेंट के लिए, तो यहां पे मैंने समराइज भी किया हुआ है, तो जो हेड लॉस हो रहा है वो हाईएस्ट है आपका ओरिफाइस में, फ्लो नोजल में इंटरमीडिएट है, एंड वेंचुरी में इट इज वेरी लो। बट इन टर्म्स ऑफ कॉस्ट इज द अदर वे राउंड। So Venturimeter is the costliest and the Orifice meter is the cheapest among the 3 obstruction flow meters. हाँ जी, clear है? Any doubts to anyone? Now I'm coming to the analysis part of this. So I have taken a generalized Wait for a second. So one question is, so which is the best? So it depends on your application. Say if you want to employ or measure flow rate in a pipeline at your home, then this is the best. In an industry where flow rate measurement is not that critical, then also these two can work. But in applications where you cannot afford pressure drop and you need to measure very accurately the flow rate, then Venturimeter is the answer to that. So depending on your application and your requirements, you will use either Venturimeter, nozzle or Orifice meter. And any doubts to anyone? So please now try to see, there's a very important concept here. This is a generalized nozzle. This could be treated as an orifice also with this curved shape, or this is a generalized nozzle, whatever you may think about it. So this is a generalized analysis which may apply to all those. So what you are able to see is when the fluid is flowing, so what do you think? Is this drawing of velocity vector correct? What is drawn here? What you are able to see?
सर इसमें नो स्लिप कंडीशन आएगी नीचे, फिर उससे वेलोसिटी बढ़ती जाएगी.
नो स्लिप कंडीशन आएगी. तो अगर एक पाइप लेते हैं हम, पाइप में फ्लो कैसे शो कर सकते हो आप? वेलोसिटी यहां पे लो है, यहां पे जाते हुए हाई होगी, और यहां भी लो है, यहां पे जाती हुई हाई होगी. तो प्लीज रिमेंबर, नॉर्मली इन लैमिनार फ्लो regime, this is the velocity profile. That is, this is a sort of parabolic velocity profile. Are you clear? So what does that mean? The boundary layer is, so the boundary layer is actually throughout the pipe. This is one case, but in some cases what can happen is the boundary layer may be like this. It is very thin, but it will finally actually become like this. So you need to consider this parabolic velocity field always. So this kind of thing is not valid, but for simplicity they have shown as with same magnitude. हाँ जी, clear है? Actual में क्या होगा? Velocity will be a function of what? Y. If this is, say, location, this is y direction, so velocity will be function of y, and the velocity will vary in this fashion. That is, if I draw the velocity field, it should be like this. That is, velocity is nearly zero at the surfaces due to no slip. It gradually increases, and then again it starts decreasing as it reaches the other side of the pipe. So this is the velocity profile in a pipe flow. So I could actually write down this as this thing. तो अगर इसकी average velocity निकालनी हो, what can I write down this as? So I'm putting here, be careful in this. This is an important concept. So if this was the actual velocity field, can I write down this as this? So this was U, and say this is U average. Can I write down this as this? Anyone? Anyone? Can I write down this equal to this? This equal to this? Here velocity is a function of y. Here velocity is not a function of y. and I have written down instead U average. So U average का formula क्या होना चाहिए? By common sense, what should be the U average formula? U dy
प्लस 2 बॉटम
0 to h, मान लीजिए ये h है, अपॉन h. हाँ जी, क्लियर है?
यस सर।
बेसिकली मैं दो एरियाज को इक्वल कर रहा हूं. ये पैराबोला का कुछ एरिया है, मान लो पाई ए बी है, ये एरिया है मान लो सी डी. तो मैंने क्या कर दिया, पाई ए बी इज इक्वल टू सी डी. ये तो मैं कर ही सकता हूं, बिकॉज इंटीग्रेशन वही तो चीज है. एनी डाउट टू एनीवन? सो दिस इज द एवरेज वेलोसिटी. सो प्लीज रिमेंबर, when you encounter such kind of a thing in any diagram, you should always see that V1 is now what? V1 is U average. It is not depicting the U actual, because U actual needs to be a parabolic profile in case of a pipe flow. And any doubts to anyone? Any doubts to anyone in this? हाँ जी बताइए.
सर वेंचुरीमीटर में कैसे फ्लो होता है एक बार?
हाँ, मैं वेंचुरीमीटर का भी आ रहा हूं. आई एम स्टिल टू कम एट वेंचुरीमीटर इन डिटेल. हाँ जी, ये क्लियर है? एनी डाउट्स टू एनीवन?
नो सर.
So now there is an important concept here before I come to Venturimeter. Now if I ask you what is the diameter of this orifice or nozzle, this is the diameter. That is D, say dt. This pipe diameter is D1. What you are able to see, you are able to see another diameter I have marked as D2. Now let me know what is D2 will be less than D1, sorry, DT or greater than DT? D2 will be less than DT or greater than DT?
लेस देन सर.
So D2 will be less than DT. And clear? So where are you applying the Bernoulli's equation? कहां पे लगा सकते हो Bernoulli's equation? Where will you apply the Bernoulli's equation? You can take one point here, the other point you will take somewhere here or here. So this is the point. So you have taken point here, and you are marked as 1 and 2. So this is 1, this is 2. So do you know what is the diameter D2 practically? Which two diameter do you know practically? You know the diameter of the pipe, you know the diameter of the orifice or nozzle, but you don't know the diameter of what? You don't know diameter of what? This D2. So this D2, which is less than DT, this diameter is called vena contracta. This is called vena contracta. That is, you get a stream of lesser diameter as compared to the diameter of the orifice. Can you suggest what is the reason for this kind of phenomena? Can you suggest? The streamline is just following this pattern, nothing more than that. So it is actually keeping up with Newton's second law, nothing more than that. But we know that this diameter is far greater than this diameter. So D2 will be less than DT, and my follow-up question is, जो ये difference है वो किस केस में हाईएस्ट होगा और किस केस में लोएस्ट होगा वेना कॉन्ट्रैक्टा का? I have given you 3 flow meters. My follow-up question is, there is a phenomena called vena contracta or a cross-section called vena contracta. My question is, in which case this diameter reduction will be highest and in which case it will be lowest? This is the first case, second, third. तो मैं इसको लिखूं डी टी और आई शुड मार्क डाउन d2 upon dt. This should be greater than 1 or less than 1? Greater than, less than, or equal to? Anyone?
Less than 1.
Less than 1. Okay, so this should be less than 1. So now my question is, help me out in this. d2 upon dt, this is for, say, Orifice. Then this is d2 upon dt, this is for, what should I write down? This is for nozzle. And this is d2 by dt for Venturimeter. What sign should I put here? Less than, equal to, greater than what?
Sir, greater than 1.
Greater than 1 तो तीनों ही है. किस केस में इसकी वैल्यू हाईएस्ट होगी? ये तो लेस देन 1 है, d2 1 d1. आप ग्रेटर देन 1 क्यों कह रहे हो? d2 तो, ये d2 जो है ये छोटा है ना. आप ध्यान से देखिए, ये जो d2 है, दिस d2 इज स्मॉलर देन dt. So d2 upon dt is less than 1. तो मेरा क्वेश्चन क्या है कि d2 by dt किस केस में सबसे ज्यादा 1 से छोटा होगा? d2 by dt 1 किस केस में सबसे ज्यादा छोटा होगा? मैं यहां पे लिख रहा हूं ओरिफाइस, नोजल, वेंचुरीमीटर. इन तीनों में से सबसे छोटा किसमें होगी ये रेशो?
जहाँ पे dt सबसे बड़ा हो.
dt तो मान लो dt सेम है, तीनों केस में dt सेम है, तो d2 पे डिपेंड करेगा.
यस सर.
तो d2 सबसे छोटा तीनों में से किस केस में होगा?
Orifice.
ओरिफाइस में सबसे छोटा होगा.
Yes sir.
नोजल में उससे बड़ा होगा और वेंचुरी में
सबसे बड़ा होगा.
तो वेंचुरी में नियरली ये 1 के करीब आ जाएगी ये रेशो. हाँ जी, क्लियर है? सो प्लीज रिमेंबर, जो वेना कॉन्ट्रैक्टा करके आपको फिनोमिना दिख रहा है, जिसमें आप देख रहे हो कि ये नोजल, ये जेट है, ये इसका डायमीटर कम हो गया, ये मैक्सिमम आपको दिखेगा ओरिफाइस के केस में, उससे कम दिखेगा नोजल में, और वेंचुरी में सबसे कम दिखेगा ये फिनोमिना. यू कैन ट्राई दिस एट होम. आप एक कंटेनर लीजिए, उसमें एक छोटा सा होल ड्रिल कर दीजिए, आपको दिखेगा इस होल के डायमीटर से छोटा डायमीटर वाला जेट आपको ऐसे दिखेगा. ये इस तरह से, बेसिकली ये इस तरह से, ये ऐसे जेट निकल रहा है, यहां पे कुछ होगा, फिर ये ऐसे होगा. यू विल सी समथिंग लाइक दिस. सो दिस इज कॉल्ड द वेना कॉन्ट्रैक्टा. दैट इज वेयर द डायमीटर इज मिनिमम. So you will be able to observe vena contracta in Orifice if you try this at home as well. But in case of Venturi, this will be nearly equal to d2 only, dt only. So it will be hardly visible to you. So one question has been asked. So it will be, this ratio will be smallest in case of Orifice and the largest in case of Venturimeter. So that is correct. Any doubts to anyone? Now I'm coming to the analysis part. So we found that because vena contracta is the area of smallest cross section and we want to apply Bernoulli's equation. So what will be Bernoulli's equation for 1 and 2? P1 upon rho g plus V1 square upon 2g plus Y1 is equal to P2 upon rho g plus V2 square upon 2g plus y2. Are you clear? And what else do we know? This is from Bernoulli's equation. What else do we know? From continuity equation. From continuity equation, if rho is a constant, what do we know? The simplest expression. A1 V1 is equal to A2 V2. So what is the problem here? Do you know A2? Do you know this area? Do you know A2 or not? Anyone?
No sir.
You don't know A2.
No sir.
तो जो यहां से निकल के आएगा सब कुछ इस एक्सप्रेशन में, उसमें प्रॉब्लम क्या? सिर्फ एवरीथिंग इज इन टर्म्स ऑफ A2 which itself is unknown. Are you clear? So I am putting here, please be careful in this. I am showing here. So this was the Bernoulli's equation. I have cancelled these terms and I have applied this continuity equation. And from this, what will I get? What will I get? If I want to find out the flow rate, what do I get? What do I get? Can you find out flow rate from these?
Yes.
What is M theoretical? This will be equal to what? Rho times V1 A1 or rho times V2 A2. Anything. So M theoretical involves which area? A2. But A2 is unknown to you. So that is the problem. So what can you do? If you want to find out A2, this is one way to find out the expression M theoretical. Then if you want to find out M practical, that is not. Now please remember this A2 is not known to you, but you know this value. So you have devised a technique to find out the A2 in terms of this. So please be careful. What I am defining now is beta is dt upon d1, dt upon d1. So what I am doing now is, instead of A2, I am replacing A2 with AT, and with this kind of manipulation, I am another time adding another term called C, that is called empirical discharge coefficient, or C. Empirical discharge coefficient, or C. So M actual will be equal to C times this thing, where I have replaced A2 with AT. So now, as a question, please answer this question. Theoretical जो आपका फ्लो रेट निकल के आ रहा है और जो एक्चुअल निकल के आ रहा है, उनमें से ज्यादा कौन सा होगा? जो थ्योरेटिकल निकल के आ रहा है और जो एक्चुअल निकल के आ रहा है, उनमें से ज्यादा कौन सा होगा?
एक मिनट.
You can see with this formula, M actual is C times AT, and beta I've already defined. Beta is this thing, that is dt upon d1 instead of d2 upon d1.
प्रैक्टिकल ज्यादा होगा सर.
प्रैक्टिकल
ज्यादा
ज्यादा
आएगा
होगा?
हल्का सा. यस सर. बीटा बढ़ जाएगा, बीटा बढ़ेगा तो माइनस बीटा कम हो जाएगा, माइनस बीटा कम होगा तो उसका रूट कम हो जाएगा, रूट कम का इनवर्स
Okay, so
बढ़
I
जाएगा.
will leave this as an exercise. I will discuss in the other class. So the answer is M theoretical will be actually what I should put, greater than or less than? So m एक्चुअल को मुझे m को अगर इक्वल पता लगाना तो मुझे c से मल्टीप्लाई करने का m थ्योरेटिकल को. तो c is always a quantity less than 1. I will let you know why it is so. So I will break for today and I will send across the slides to you and also communicate the lecture number up till which the MSc syllabus is there. Okay then.